All right, so this is the second part of the class on Eclipse, and what I would like to do is I would like to continue a lecture on how you set up projects in Eclipse and how you set them up for debugging, and give you a few examples of this. So in the previous lecture, we looked at how to set up a project in there, and I showed you that if you allow Eclipse to understand where the header files for the projects are that you're going to use, so if you expose it, for example, to the deal.II header files by passing the path to these header files to the project, then it can help you a lot with auto-completion and can help you with renaming variables, and there are many, many more things that I haven't even touched at. What I would like to show you now is how you run a target in Eclipse. So Eclipse can do all sorts of things that avoid that you have to go on the command line, that you have to use other tools for things. So everything can work inside Eclipse. So let me show you how this works. So we've already set up this project, and what I would like to do is I would like to go to the Make button over here in this right panel. So we saw the outline before. Now I'm going to Make, and I'm going to right-click on step 1. And it asks me, or it offers me, to add a new target. So when I say a target, we compile our software with a program called Make, and that is driven by a make file. The make file is set up by when I call cmake. So when I click on New here, it asks me, what target do I want to enter? So the first target you typically enter is something that is called all. When I type on the command line make all, so let me go back to the command line. When I type make, and let me clear my screen here. When I say make all, then it's going to compile my object file, or it's going to compile my source files into object files and build the executable out of it. And the executable is called step 1. So I have that here. So if I type /step1, that's when it executes step 1. And if you look at the time, so it is 1040 now. The files grid 1 and grid 2 were generated at 1022, and now they have just been regenerated at 1040. So when I type make all, or just make, it doesn't matter. Make all is an equivalent of make. Then it rebuilds the object file. So when I create a target over here that is called all, then I can double-click on it, and it's going to execute make all. So let me get back at the tools at the very bottom here. There is one view that is called console. So if I go here, I double-click on all, it's going to execute make all here. That's what it says here. And in this particular case, it said that there is nothing really to do, because it had just compiled the file. But of course, I can, for example, change refine global 4 by refine global 3. I save this file. Let me call make all again, and it's going to show how it's building the object file step1.cc and then linking the executable. Another thing that I might want to do over here is that I add a target that I call make clean. So make clean typically removes the object files and the output files. So if I double-click now on make clean, it will have removed all of that cruft. So if you go here and you look at the files, you find that the executable in particular has disappeared. Okay? The output files have remained. Now, the last one that I want to add here, so I click with my right mouse button again, I'm going to add a target that I call run. So I accept this, and so if I say make run, it's going to build the object file, which it has deleted when I clicked make clean, and then it's going to run the output. So for example, if I double click on here, then I get to see the mesh that it has produced. This is the hyper-L. If I want to go back, for example, to the hypercube, okay, with the triangulation, sorry, the variable is of course called mesh. Let's say from the hypercube from x equals -1 to +1, and the same for y. So let me save this. Let me call make run again. So it's compiling the object file again. And it complains that there's an error now. So that was not the point in my lecture where I wanted to show this, but this is just as well. So what I can do is I see the error message down here, and I just double click on it. And it's going to say, well, it expected a semicolon before mesh. Mesh is at the very beginning of this line here. Okay, it even shows me the error message from the compiler in this place. So, of course, the semicolon was missing at the end of the previous line. So let me add it here. Let me call make run. Tries to compile again. It should succeed this time. Okay, it has succeeded. The underlined error message in the editor window has disappeared. It has built the executable and has executed it. And if I double click on grid1.eps here, I get back to the original square, right, which is appropriate when I execute Hypercube. So this is how I set up the make targets in Eclipse. And the primary point is not because I don't want to go back and forth between Eclipse and the command line. I can do all of these things on the command line, of course. As a matter of fact, I often prefer doing things in the command line because this is how I grew up as a computer programmer. But the advantage of this is that if I set it up inside Eclipse, that I get to see the error message inside Eclipse, and I can double-click it, and it automatically opens it in the right place in the editor. This is something very useful if you have big projects with multiple files, because then you just make, let's say you click on Make All, and it's going to compile all of the files in your project, and the error messages might be from files that you don't have open. It automatically opens the file if you double-click on it and jumps to the right position. So it's very, very convenient to find the places where the error message happened. The next thing that I would like to show you is how to actually run something inside Eclipse. So I can double-click on Make Run, but that's not always the most, let's say, that's not always the simplest way to do it. So what I would like to do is I would like to go here in Eclipse to the Run menu, and I would like to add a run configuration. So a run configuration is essentially, I want to add the name of an executable and potentially command line arguments that I need to add. Okay, and it has already added a step 1 default here. So it has found that there is an executable called step 1 in this directory, and it has added this. If that doesn't show up in your case, you just double click on C++ application and you select the executable. So I'm going to say, okay, let me say run, for example. And what it's going to do is it's going to run this in the console window. Now, it turns out that step 1 does not output anything on the console, so there's nothing to see here. Maybe we should change this. Maybe we should just, in first grid, say standard cout first grid end line. So if I save this, and if I want to run this, so this button here says run, what it's going to do is it's first going to, it's first going to build it, and then it's going to run it, and now you see the output here. So typically in this window down here you will see the output. Now a run configuration is not all that interesting by itself. It's interesting primarily because I can use a run configuration to debug a program. And what I would like to show you is, let's say, what will happen if you make a mistake in deal.II. One of the things that typically happens is that deal.II will throw an error. And the way this works in practice is that when we throw an error, we abort the program, we print an error message, and then we abort the program, and that is your cue to figure out how to go from the error message to fixing it. So let's say, for example, I had accidentally exchanged the left and the right boundaries of the hypercube. So the hypercube is from, let's say, A to B, and I had an A that is greater than the B. So let me save this. Let me try to run this here and see what happens. So if I run this, it's going to compile it again. Okay, it's linking it. And then it shows me an error message. And the error message in this particular case reads as follows. So an error occurred in line 164 of something, 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 grid generator, okay, in function grid generator hypercube. And then it's going to show me what actually happened. So the condition was that left must be less than right, but it wasn't. Left and right are the two arguments. And it says invalid left to right bounds of hypercube. Okay, so that already gives me a hint of what happened. It shows me in particular at the bottom how I got there. So I started in function main called first grid, and first grid called grid generator hypercube. So typically, by just looking at this, I will be able to tell in 90% of the cases what went wrong. I can see how I got to the place where the error happened. I get a description of what the error is, and most of the time, by just looking at this, I already know what's wrong. But let me show you what happens in a case where you don't know what's wrong. So let's say I can't figure it out. The way to do this is to debug this program, and a debugger is a tool to help me with this. So what I'm going to do is I'm going to click on this bug, and it's going to take a little while for this to happen, I think. Yes, and then it asks me, this kind of launch is configured to be opened in a debug perspective. So what Eclipse is telling me here is that there are two different layouts of these panels inside Eclipse, namely one that is tailored to writing programs, that's the one that you've seen so far, and that there's another perspective that deals with a layout of these various different panels around the window for when you want to debug a program. And so let me show you how this looks. So if I click on yes, and I'm going to say remember my decision, if I click on yes, it's going to jump into the debug perspective. And you can see which perspective you're in at the top right here. So I can switch back between the C++ development perspective and the debug perspective. So there's a lot going on this page here. Not everything is really important right now, but what you see is the following. So when I clicked on the beetle, it started the debugger, and what it does in the debugger is that it stops in a place that I can see here. So this is in this perspective here, I have information about where the program currently is. So it stopped in thread number 1, while there is only one thread, in the function main. That's right here. Okay, and I can with these commands here, I can jump over a function. So if I clicked on this button, it would jump to a second grid, or I can go into it. So I can go into this function, and I would end up here. Okay, let me just execute this one command. So I step over, and you see at the very bottom that it has printed some text, namely the text that came from this particular line. In your case, you're interested in running this program until you actually hit the bug. So I'm going to say here, resume. Resume means just continue running until something happens, until the program either ends or is aborted. So I'm going to continue. And of course, it was aborted. Okay, so what we now see in this top left window here is that it started at main called first grid called hypercube, hypercube called assert issue error assert 1, and so on and so forth. These are all, of course, functions that we're not interested in anymore. They just aborted the program. The ones that we are interested in is this one here. And so if I click on it, you get to see where we actually are. So we're in line number 30. That is this line. You can see this here, that this is where we are with this little arrow. There's a way to configure Eclipse to show line numbers as well. It's a little bit hidden, but if you want to find out where this is, go to the deal.II FAQ page on Eclipse, which has a lot of information how to configure Eclipse in such a way that we find it useful. Anyway, so we're in this line here. And if you go back into this call stack, we call this a call stack or a backtrace, this place called grid generator hypercube. And so if I click on this, it should have shown the place where this was originally compiled from. I made a little mistake in that I removed these files yesterday. Let me pretend that that hadn't happened, and I'm going to simply copy this to the same place where it was supposed to be. So precompiled, deal.II precompiled is the directory where I compiled deal.II from before I installed it. So let me go here again. So it should have looked like this. So the error happened in this file here in function grid generator hypercube, and you see again the little error. This is where it happened. So there is an assertion that says that left should be less than right, and if that is not the case, then it should output a message called invalid left to right bounds of hypercube. So let me go a little bit higher here to see the context. So this is the function grid generator hypercube, and it has 3 arguments: a triangulation, a left, and a right double argument. So the condition that is asserted here, that is checked, is that left is less than right. And of course we know that the values that are passed here are 1 and -1, so they do not satisfy these assertions, or this assertion. But I can also see this up here. So at the top right, I have a perspective that shows me all of the local variables. So it shows me, for example, the triangulation, and I can get more information by looking at, by pushing this down button. A triangulation is a complicated object, so there's not that much for us to learn right now, but I can look at the value of left, and I can look at the value of right. And it shows me that they're 1 and -1. And that, of course, explains why the assertion fails, right? So basically, by following the backtrace of the debugger in Eclipse, by showing how I got to the point where the error actually happened, I have already learned a lot about why that error happened. And typically, if you see where it happens, if you look at the values of local variables, you already know what needs to be fixed. So finding the place, seeing the error message, seeing the call stack, typically gives you all of the tools you need to fix an error. Of course, this would have been much more complicated if deal.II would not abort your program. So let's say if you had the situation where it would have just silently accepted left equals 1 and right equals -1 and create a mesh, for example, that is inside out. In a case like this, you would have a much harder time because all you get is that the computations produce something that is not correct. Right? So you would get, let's say, nonsensical results. What you will find very helpful in your further work with deal.II is that deal.II is littered. That's maybe the wrong word. There are thousands of places in deal.II where we check arguments with these assert statements, where basically every function you call in deal.II verifies that the input arguments that you pass in have values that make sense. So in a case like this, that the left edge is to the left of the right edge of an interval or of a cube. These sort of things happen all the time. Other places where you can make mistakes, for example, is, let's say you have a vector of length 10 and you try to access the 11th element. Or in C++, because we start indexing from 0, if you have a vector of length 10, then even accessing element number 10 is a mistake. You will not be able to do this. You will get an error message, and by looking at the backtrace in Eclipse, in the debugger, it will make it a lot easier for you to find out what exactly it is that went wrong. So these are the sort of things that I wanted to show you how to use this debugger. What you will find yourself doing multiple times is that as you go through the various different tutorial programs, as you play with them, is that you will set up multiple projects. So let me stop this run here. I have found out what is going on, so I'm going to terminate the program. I'm going to jump back to the C++ perspective. I know what I did wrong, so I can close this file again. I can close this file. I'm back at step 1, so I know that I need to fix it like this. So if I wanted to have an additional project, for example, let's say the next thing that I would like to do is I would like to work on, I don't know, step 46. Let's jump a little bit ahead. So I'm going to ask again for a makefile project with existing code. I'm going to browse for a location. I'm going to go to Bangerth, mass 676, deal.II, examples, step 46. Okay, and finish. So now I have 2 of these projects, and what you see is that I can expand them here. It also has a file step 46, which is a lot longer in this case, for example. Again, it doesn't know the locations of the header files. I can add this again. Let me minimize this one here. This one, of course, is a much more interesting outline because there's many more functions. So it shows all of the header files here. There's many more functions that happen here in this program, and so it's much more useful to use the outline if you want to find a particular place, or like I said before, if I just hit Ctrl-O and let's say I call assemble, I just type ASSE and it filters it to only show those terms that I'm actually interested in. So let's say I want to jump here. This is the declaration of assemble interface terms, and if I go to assemble interface terms down here, I actually jump to the location. Again, I would need to add makefile targets. So right now there is no targets in step 46. But I can do this in exactly the same way. I right-click on this here. I would say new, and so on and so forth. I can, just like before, say run, and I can add a run configuration to it. So in this case, I need to add another C++ application. So I double-click on this. I would browse for an application. So I need to go to step 46. This is not compiled yet, so let me go back to deal.II example step 46, cmake -d, deal.II, dir equals home Bangerth bin deal.II dot, okay, I can type make. So it compiles this. There is now an executable make 46, step 46, which I can choose. So, and so on and so forth. One of the things that you will have to find out is when you just hit run now, because you're in the, because I have made step 46 the default, this is what it's going to run. If I were back in step 1, it will still offer me step 1, because this is the only executable associated with each one of these projects. So it's fairly easy to work with a lot of different projects in Eclipse. You would just open them all. You can close them at any given time. If you don't want to work on one, you would just go back here, for example, and you would just right-click on it and you would say close project, which, yes, I want to save it. So it just shows that this folder still is here, but it's, let's say, inactive right now, whereas step 46 is active. And if I want to make it active again, then I would just open the project here, and that makes it active again. The difference between an open and a closed project is essentially whether it tries to find symbols from one project in another, or oftentimes what I want to do is if I have many files in each project that I want to open a particular file, so I type Ctrl-Shift-R, which allows me to just enter any part of a file name, for example. It will only offer me those files that are relevant for an open project. As I say, there's much more to learn about Eclipse. We have put a lot of our information about Eclipse into the deal.II frequently asked questions. So if you want to find other things that you can do with it, or if you ask, how do I install multiple targets and so on and so forth, that is all described in the deal.II wiki, where the FAQs are hosted. And in particular, one of the things that you find there is a list of common key commands, things that are that you frequently will use and that are very convenient to know. So take a look at the table at the bottom of that page in the FAQs. That's essentially all that I wanted to show about the environment Eclipse, and that's the tool that I'm going to use for the rest of this class whenever we need to edit something.